Okay, not sure if it's quite my personal experiences, but I guess it's really the Es'Hail story. So those of you who don't know, I want to give a little bit of background about the project, how it all came about, and some of this is from AMSAT DL and pinch some of their slides. Talk about the wideband TV transponder, and then talk about practically receiving it by either of you, and then practically about how to transmit. And there's a couple of videos in here as well of stations who have been seen active. So the official name is Q Oscar 100 because it's Qatar. It's the Qatar Oscar 100 is the name of the amateur transponders, and they are hosted on board the Es'Hail-2 satellite, which is owned by the Es'HailSat Corporation, which is the national satellite company for Qatar in the Middle East. This project is pretty unique because it's the first time ever there has been an amateur transponder or facilities on a geostationary satellite. All other satellites have been what they call LEOs. Thank you. Low Earth orbit satellites, which means they're not a fixed point in the sky, but they come over and have an orbit of time of about every 20 minutes. No, every hour and a half they'll come over for about 20 minutes, which involves having to track them across the sky. The reason why this one is so different is because it is in an orbital slot, just like Sky is. It's on a big geostationary satellite, 22,000 miles out. And the only way we could get an amateur payload on there is by courtesy of a proper satellite company. And so Oscar 100 is piggybacked on board this satellite run by Qatar. How that came about was Peter DB2OS was invited to take part in an exhibition in Qatar in 2012 talking about the future of amateur radio, and there was a formal visitation by the Deputy Prime Minister, who happened to be A71AU, who is also President of the Qatari Amateur Radio Society. And from that he talked to Peter, and I think there was a bit of a send my man an email and we'll talk about this. And from that it developed into that Qatar were launching this satellite. There is already an Es'Hail-1. They were launching their second satellite, and they really wanted to do something a little bit different. And so they were convinced by the Deputy Prime Minister that this would be a good idea. And so AMSAT DL provided the specifications to Mitsubishi Corporation, who built this payload, and it is essentially two transponders. So there is two receivers, one horizontal and one vertical receivers, one for narrowband, one for wideband, and they go into the matrix which is on board the satellite and comes out on one of the or two of the spare TWTs on the satellite. So the investment Es'Hail have made in doing this is not insignificant. It's probably millions of pounds to custom build this equipment and put it on the satellite. It was launched by SpaceX on a Falcon 9 from Cape Canaveral in last November, and some of us were lucky enough to go and see it. And you may have seen the SpaceX video. And one of the really cool pieces for me, we've all seen rockets go up, but in the video, because SpaceX do this, you actually see the satellite itself detach from the launch vehicle. And that is Es'Hail-2 drifting off into the distance. Picture above is the Es'Hail and Mitsubishi people with Es'Hail in the background, so that's the size of the satellite.
Oh, big on bunch then.
It's pretty big. It's not a fun cube. It's not a cube satellite. I think it's about 6 tons. I think it's in that order.
That's double-decker bus size.
Yeah, it's a proper satellite.
Yeah.
And launched in November, and after November everybody's saying, when? We knew a little bit more because we were talking to AMSAT DL. They went through a whole load of tests because Mitsubishi wouldn't have got paid by Es'Hail until they commissioned all of the, tested and commissioned all the transponders. Some of that included the amateur transponders, and just before Christmas we all got very excited because it was turned on for a few hours and some of us caught it. Then in January, Es'Hail spent quite a bit of time doing their commercial customers, and so I think the first commercial satellite pay TV system was launched in late January, and then in middle of February, and it was February the 14th, the narrowband transponder got turned on, and I think it was the Thursday, so it must be about the 17th when the wideband transponder got turned on. It was actually there was a Prime Minister's visit to the Es'Hail facilities, and it got turned on for that, and they ran the beacon with the message running, so that was running during the Prime Minister's visit, and after that it was available for use. This is a AMSAT DL slide. Why Es'Hail? Well, apparently it's Es'Hail in Arabic means canopus, which is the name of the star which become visible in the night sky. So it means that traditionally the sighting of Es'Hail means that winter is coming, and so good weather will soon be with us, because they've got a slightly different idea of winter to us. So that's what Es'Hail means. One slide on the narrowband transponder. It's up there, you can find it. 250 kilohertz-ish. And the difference between it and the transponder we are interested in is that it is vertical, whereas so that's 12 volts to the LNB, whereas the wideband one is horizontal. But you can actually hear the narrowband transponder when you're running 18 volts to receive the wideband transponder. It's very loud, it's very sensitive. Those of you who haven't played with it yet, well worthwhile taking a listen for it. Lots of activity on it. So why is the coverage so good? Well, that's mainly the reason because it's got a 3D beam width at 17.4 degrees and it's a horn, and so it covers basically 1/3 of the Earth. And that 1/3 of the Earth is that. And we were having a discussion earlier. There is no fall off. Essentially, coverage down here, or where we are, is within 1 or 2 dB of what it will be in the centre of the spot beam. Es'Hail is actually centred over Africa, but it goes right down. I think this is Singapore just here, isn't it? I think merging into Indonesia. Yep. Yeah. So I think on the narrowband segment they've heard Thailand, Brazil, and everywhere else in between. Unfortunately, TV-wise, it seems to be mainly European, but we know that some guys down in South Africa are buying bits. I personally have worked somebody on Mauritius on the narrowband segment, and they said they are getting some equipment for TV. So that's the coverage, pretty phenomenal. So let's talk about the wideband transponder. It's 8 megahertz wide, and it's specifically for DATV use. Many potential modes, and this is one of the problems we foresaw before the launch. That you're trying to tie down these combinations. How on earth are we going to be able to know what people are doing? And so Dave and I had meetings with AMSAT DL 2 years ago, and we said because of this it's going to be very difficult to define band plans that accommodate all of the modes, and also then we believed we need some form of coordination. So the band plan, which Dave came up with, it's not as difficult as it looks. Essentially what we've done is divided it into a 3 megs, 3 megs and 2 megs. So in here you can either run 2 megahertz or 2 1 megahertz. Same here, 2 megahertz or 2 1 megahertz. And then at the far end, at the top end, you've got RBTV, and that can be divided into 2 333s or 4 125s. So if you get the picture, this piece here is taken by the wideband beacon, which is being demonstrated here. So that's a 2 megahertz or 2 megasymbol wide signal at the bottom of the band, which still leaves us 6 megahertz to play with. Looked at it another way, this is the way I look at it. The bottom 3 megahertz is for the wideband, the middle 3 megahertz is for 2 or 1 mega, and then the top 2 megahertz can be used for RBTV. So once you get your head around it, it's not actually that difficult. It just seems a bit complicated on paper. But once you get on the receiving it and using the spectrum monitor, it does feel logical. It's much more complicated on paper than it is when you're actually playing with it. So, how do we go about receiving this? Well, as you've seen this morning, it's relatively easy. A downlink frequency is 10491 to 10495, if you're talking in terms of wideband and narrowband segment. And that, luckily, is within the bandpass of a standard consumer LNB. So the bit of electronics that goes on the dish, on your standard Sky dish, will cover this frequency. You need, for the TV segment, you need to provide it with 18 volts because we're on horizontal. And whilst a normal Sky dish would probably receive the beacon, you need to think about a phase-locked loop LNB to give stability to go down for the narrower signals below 1 megasymbol. And there are a number of these. The problem is it's difficult to recommend exact types because they change relatively quickly, and quoting eBay numbers, which is where we all tend to buy them from, is a bit of a fool's game because they sell out and then they'll put them back up. But what you need to look for is either something like an octagon or a Goubet unit. There are a number around as well as those, but generally you'll be paying less than £25, probably less than £15 for a phase-locked loop LNB. And if you're thinking of doing this, get hold of one of your friends who's done it, or put a question on the BATC forum as what the current good LNB is. There are Kuna doing an LNB, but they're significantly more expensive, and I think for our applications I'm not sure that they're really much better. There are also a lot of talk about whether you should then lock the phase lock loop to 25 with a 25 meg source. To be honest, for digital TV you don't need to do it. In fact, it can be to the detriment, because unless you do it properly you can cause phase noise problems, which will detract from the performance for DATV. If you're going on narrowband, very different matter. These typically can drift 25 kilohertz between hot and cold on a day. Short-term drift is quite good, so you can follow the sideband, but if you're doing narrowband you really need to look in that to lock. But that's an entirely different subject. So that's the LNP piece. The problem is that with that frequency, if you run the standard LNB, it puts the IF outside a standard consumer's tuning range. So 10491 minus the LNB frequency comes out at 741. Standard set-top box is 950 to 2150. So can you use a standard set-top box? Well, you can, You could move the LO in the LMB, and I know some people have done that.
I think the Kuhn one's has a...
I think the Kuhn one does have a higher LMB, so it comes out at something like 1100 megs, 1150 megs. You can convert the signal, the 750 meg signal, up into L-band. AMSAT DL have a design in their shop. People are talking about using the old range extenders for the old Astra boxes, you remember?
Got one, yeah.
Yeah, now...
The direct TV ones.
Yeah, and I think there may be an issue there because unless they are crystal controlled, you are adding just yet another frequency stability issue. So I'm not sure about that, but potentially. If you did that, that would enable you to use a standard set-top box, and it would need to be a modern set-top box. The best thing is it'd have to be an HD free-to-air set-top box, so it would do DVB-S2, and you will be able to receive the beacon. And there are people doing that and receiving the beacon, better than we're receiving the beacon here. They're doing that, and it definitely works. But what you won't be able to do is to receive the reduced bandwidth TV signals below 1 megasymbol, because the DVB specs only go down to 1 megasymbol. There are, I believe there is one set-top box that we know about which will go below 1 megasymbol, but I'm reliably informed that the user interface is challenging. Where is he? Where's Sean? I think Sean used the word challenging.
Yes, I gave up on it.
So they will, but it's not ideal. And so we would recommend that you use a wider frequency range tuner, and that's really where mini-tuna comes in. Most of you here know about this. It's the hardware which somebody's pinched.
Oh, it's actually a back box.
It's in the box.
When you were sizing up how bigger.
That's why I'm re-nicking it.
Yeah. You put it there.
So this is the hardware we're talking about. The mini-tuna, 4 major components that we sell: the PCB, the tuner, the USB, and the 1-volt regulator. All of the rest is available off eBay. And this, along with the PC-based software that we all use, the mini-tuna software, will give you a flexible receive system that does all of the DVB-S modes and the MPEG modes, and covers 143 up to 2430 megahertz. So it covers 740 natively. So you can just put this on the end of your USB tuner, on the end of your phase lock loop LMB, and into a PC to receive the signals.
So, quick question: does mini-tuna run on Windows 10?
Yes,
Yeah, it does.
that's the platform it does run on. It doesn't run on Linux, Mac, Raspberry Pis, BBC Micro. It's a Windows-based platform. Actually, it doesn't run on Windows XP either. It runs on Windows 7, 8, 9,
Or
10.
Or 98.
Probably not. So once you built this, once you put your dish up, or what's there, well, there's normally, I had to rewrite this slide yesterday evening. There's normally a 2 megasymbol beacon playing a loop video about Es'HailSat. The reason why I put normally is because yesterday afternoon it went off. It had a failure. Just as we were going to demonstrate it here today, the beacon went off for the first time in a month. Most of the signals are 1 megasymbol, which I would think these two are, and 333. I think that's actually a 250 kilosymbol. And some stations have tried 88 kilosymbols, so that's about 100 kilohertz wide. And even yesterday there were guys playing around with 32 kilosymbols, so that would be about 50 kilohertz wide. And they were getting, you wouldn't play sport over it, because you would get contest numbers over it. And there's this thing called DVB-S2 is preferred. And why is it preferred? Because it gives us 2 dB more signal, or equivalent of 2 dB more signal. And as you'll hear later on, you're going to be struggling on uplink power to get in to run any bandwidth above 125. So, as you saw, you've got a 2 meg signal, you've got a 1 meg signal, a 1 meg signal, a 250 kilohertz. So how do you know what's in there? So you've got your mini-tuna. I'll come on and talk about how you put up a dish. How do you know what is on there? And Dave and I sat down and thought about this early on and knew that this would be a problem because TV receivers, DATV receivers, need to know what they're receiving. They basically need to know the modulation, the FEC and the symbol rate. And so we decided we needed some form of coordination tool which will allow you, a station who's transmitting, to say, hi, I'm 250 kilohertz, 2/3 FEC. And so we built a ground station down at Goonhilly which provides 2 things. It provides the web-based spectrum monitor and it also provides the SDR so you can listen on the narrowband segment. Phil M0DMY has enhanced it since it went on live, so it will give an approximate symbol rate for each signal. So if you look on here, this text here is Phil is doing an approximate sample on it and is giving an indication. So it says here 250 kilohertz, 497751, so that's 10497. So he's estimating the symbol rate and the frequency. So you already know some of the information without even looking at the chat box. On the side we've got a chat box for coordination between the stations and give general information, and it's really turned out to be an essential tool to enable this wideband transponder to be used. And this is what it looks like. Hopefully most of you have been there. It just is a standard web browser, and on here, this is actually this will be a unique picture.
Yesterday afternoon.
A unique picture because this is yesterday afternoon. Because normally there's a great big bump there, which is the beacon. Okay.
In fact, there's a bit of beacon there. You can see it.
Yeah.
It's a spurious beacon.
There is. Yes, because the beacon not only went off, but it went spurious. But we don't tell too many people. Well, we are now. So what we've got here is, that's a 1 mega symbol, that's 500 kilohertz, and that's 250 kilohertz.
Did you see on the BBC News the Sky shut down yesterday? Yeah.
I don't think we need to know
Sky
that. And then down the side here, in fact it was taken at 5:13 yesterday afternoon. The chat, a list of who is actively logged in and on the chat, and what it's saying is there's 169 users currently viewing the page. So it's turned out to be immensely popular. People are now saying this is the place to go to if you want to know what's happening in ATV at the moment. There is so much technical information and good news being imparted on here. It really has turned out to be a worthwhile place just to monitor for that, if nothing else. But it enables you, if you've got a receiver, to go, so this one's on 1094.750, 1 mega symbol. You dial that into mini-tuna and you should be able to receive it. It's located at Goonhilly. We're lucky enough to got our own building with the dish just outside the building. We've got this room here, and essentially the dish with a locked LNB. Dave did the lock. It's an octagon quad, and that feeds 2 AirSpy receivers, one of which goes off and does the wideband, the narrowband web SDR, and the other one does the wideband spectrum monitor. GPS locked via a Leo Bodnar device and 25 megahertz reference going back out to the LNB. So, receiving in practice. I've got no idea whose picture that is, but it was a nice picture on the web. So the message is, standard satellite dish, standard LNB, have a go. So for receive, I would suggest you ought to aim for a 1 metre dish. The next thing is to check your direction using dishpointer.com. Dishpointer.com, you type in your postcode, type in the satellite you want to receive, and it will give you a Google map, and it will say across that neighbour's house there, or above that neighbour's chimney there, and it will tell you the azimuth and elevation, and you can move it around your garden so you can see where you're going to put the dish, exactly what you're aiming for.
I actually found, just to mention, Dish Pointer Pro I bought as well for the iPhone.
Okay.
I actually found a better one, which is a lot cheaper, and it's called Satellite Pointer. And it really is.
There's quite a lot out there.
Right.
Yeah.
Got my house. Good.
All of this is written up. It was written up in Ragcom, it was written up in CQTV. There'll be a bit of a revisit this time from Ian telling his personal experiences. So basically, point your dish in the right direction, right elevation, and then align it using the commercial TV services that are in the same orbital slot. Coming from a satellite called BATC, and the one we talk about is the BBC Arabic service. And that is on 12597 megahertz. If you don't want to be messing around with putting in offsets, etc., that is on a Serret tuner. You can put in 2246 as your frequency, 27500 megasymbols horizontal, and you should get it at somewhere around 10 or 11 dB MER. And that's a lot easier to find than finding Es'hail because it's louder. Then, once you've got that, at that sort of level, you can then tune down to the beacon frequency at 10492, and you should see the wideband beacon in DVB-S2 at probably, depending upon your dish size, 6 dB if you're using a 1 metre, 5 dB on an 80 centimetre. What are you getting here, Ian? 5 dB on a
18.
There we go. These numbers are pretty foolproof. Everybody seems to be in the same order. So these are available on the wiki page. So once you've got your dish up, you can check that you've got it correctly aligned by looking at these numbers. And it's a wiki page receiving Oscar 100 DATV signals. Once you've done that, you're fit to go. You should be able to receive, particularly if you're up at 1 metre, you should be able to receive most of the reduced bandwidth TV signals on there. You'll find 80% of them are below 1 megasymbol. The majority are between 125 and 500, 333, 250 kilosymbols. But you'll see some experiments going on between 66 and 80 kilosymbols. To receive the narrowband signals, you really need to check your LNB frequency. It's all very well typing in 9750 as the offset, but what we found is that generally the octagons in particular are about 100 kilohertz high. And how you do that is you set your system up, you then listen to the L-band feed to an RTL SDR or some form of SDR, have a listen to the narrowband beacon, and that is on 10.489.5, which should be on 739.55 on your SDR. It's easy, we could do it here. You just take the L-band feed and put it into your SDR. Don't forget to put volts on it. So if you listen for it, you may find that actually it's not on 73955, perhaps it's on 73961. Okay, so now work out what your offset is. So take the beacon frequency, 104985, 1049.5, take off the frequency you're actually hearing it on, and you end up with what we call the offset, which in this example case would be 9749.89, and put that into your offset box in your INI file so it appears here. In fact, somebody's done it on this one, because this one says, and I hadn't looked before, this one says 9749995. And the reason why you're doing this is because when you're down at symbol rates at 125 or 1, you're talking in terms of signals which are only 150 kilohertz wide. And so if you're 100 kilohertz off frequency, it will make it much more difficult to receive those signals. Now what you will find is that will drift as the sun shines on your LNB or not. Probably drift about 50 kilohertz, I think that's what we're finding. So that's an approximate number, but it's a lot closer than if you just put in 9750, because that's what it says on the box. So do that calibration and put it in your offset, and you'll find that you should be able to receive the narrowband signals. So here's a bit of an example. I must have taken this one the day before yesterday. So this is the spectrum monitor, and there were 3 signals on there at the time when I took it. So this is the beacon. And by the way, we've got AMSAT DL's permission to use this space here for FM TV talkback. So as and when we get round to it, everybody's just bogged down trying to get the TV running. But one of the future things to think about is there's a bit of spectrum just here, and we've got their permission to use it for, ATV coordination, that's the word I should use, not talkback. And I didn't use the phrase FM either. No. That's the beacon. That's a big 2 megasim single. I'll take offers on who that might be from those in the know.
Guide.
0 BHF. And there's a little signal down here. So what was that? Well, the little signal was Colin, G4EML. And this is what he looked and sounded like.
They run the Guildford repeater.
Probably.
G4EML.
250 kilosymbols.
I'm a bit trouble knocking my signal then, but I think it's coming in through okay now.
Ports down. Ports down with line.
So that's with about between 25 and 30 watts to a 1 metre dish. Using the Portsdown transmitter with a pi cam. Can't move the camera around at the moment, but I'm hoping to get that sorted soon. But that appears to be working fairly well. I'm getting only about 1 dB MER on the receive. But I'm actually hearing myself come back quite well.
So we'll tell.
Bit of a delay, as you can probably hear. It's a bit off-putting, but it's working, so good.
So that's an example of a reduced bandwidth signal. You heard from Colin what he's running. And actually for 250 kilohertz, 250 kilosymbols, that's probably about 100 kilobits of video. 120.
Depends on the FEC,
Yeah.
probably nearer 200.
Yeah. So not bad at all.
Used to run video conferencing with MPEG-2 over ISDN 128,
Yeah.
didn't you?
Yeah. The interesting comment about the delay, of course, it's about 2 seconds. And what this enables us to do is not only do we have look-through, or whatever you like to call it, we can also run duplex. So you get people, Colin, KLB and Mike, MJW in particular, hold duplex QSO. So they're both transmitting at the same time. And there's about a 4-second delay then, because you've got the double hop time. All right, the other big signal is our friend.
I like that show.
So
Proper radio.
now Guy goes the other way. He's not. His brain is not in the reduced bandwidth, small as possible. It's good club. He's in the I like to run lots and high definition, high quality. So this is
it's running stable. I connected the dashboard. I will show it later on. I made a small dashboard.
I don't know what he's talking
of it.
about though, by the way.
And the data is being put into a storage on the internet, and of that you can have graphics or go meters.
It is green screen.
And I can see in an instance
He's
if
tidied up.
the device is operating right.
Yeah. So
He's actually sitting in front of palm trees, isn't he?
It's just unbelievable, isn't it? But you can see I think he is actually HD, isn't he? I think he's 1920 by 1080. So that's full HD and 2 megasymbols. And the great thing is, of course, they were both on at the same time, and there was room for more. You know, we've had times when there's been 5 or 6 signals up there. So that just gives you a contrast of the two types of signal. Now, to run 2 megasymbols requires a fair amount of power, because as Dave explains in his article in CQTV, which is coming out next week, it's all about power density, because as you go out 2 megasymbols, you've got to get that much power into the satellite, whereas with narrower signals it's easier to get a big signal. And so that's why the numbers we'll talk about in a minute are based around some of the RBTV signal bandwidth. To do 2 megasymbols, he runs a 3-meter dish and about 50 watts. So, you know, he's a fairly big signal. And in fact, we've had to ask him to turn it down a little bit, because he was running into saturation on the transponder. He was running so much power that he was reducing the power available for everybody else. But it gives you a demonstration of what you can and can't do. In fact, when the beacon went off yesterday, a couple of us actually played around with wideband signals as well, and yeah, it's got potential. But you know, that type of quality is possible. So let's talk about transmit. So the transmit is on the overall segment is 2401 to 2409, TV being 2402, 2403, no, 2401, 2409, yeah. Be warned, it is the Wi-Fi band.
I know. That's
So
why I like it.
Don't think you can mount a Raspberry Pi in your box and can remotely control it in the shack over Wi-Fi, all right? Because you'll run into trouble. I guarantee you won't be able to turn it off, all right? So duplex is easy, as we've heard, because you're transmitting on 2.4 and you're receiving on 10 gigs. So duplex, you don't have to do anything, it just works. We're saying 30 watts into a 1.2 meter dish. We discovered you must put the PA at the dish and keep that feeder incredibly short. You need less than 1 dB here, otherwise you're just throwing away power. And what you will find is, as I found, that an offset dish is much easier to manage than a prime focus dish. The problem with a prime focus dish is your focus is up here, you've got to bring the cable all the way down, back down here. When I started on prime focus dish, I had nearly 2 dB of loss. With a offset dish, you can literally just hang it there.
So no.
What about a Cassegrain disk?
Yeah, you could do Cassegrain. Yeah, I mean, any dish will work. The message is keep the feeder short. Yeah.
No, so you're saying you had your receive LNB and the transmission on the same dish?
I'll come on to that, but
Okay.
yes, that's there. So that's the transmit patch, and there's the receive LNB. And I'll talk a little bit more about it, but essentially this is the weapon. And we keep talking about DVB-S2, and that's because DVB-S was the original satellite standard. About 5 years after DVB-S came out, which is the one we've all implemented, DVB-S2 came out, And essentially, for a given signal strength, it gives you about an extra 2 dB, but is much more complex to code in modulation terms than DVB-S, which is why the industry started at DVB-S and why we have adopted DVB-S in things like ports down, because there is an added complexity to decoding or encoding and decoding DVB-S2. However, it is significantly better. So, a pointing stick. So, if you take it that this is the carrier to noise in dB, DVB-S comes in here, so the various modulations and FEC rates for DVB-S are here. This is QPSK modulation down here, so we'll talk here. If you then come across to here, you will see that this is DVB-S2. You don't need to take anything away other than the difference between that dot there and that dot there is about 2 dB. So all other things being equal, if you just switch from DVB-S to DVB-S2, you gain 2 dB. And by the way, the Shannon limit, which is the theoretical limit on modulation schemes, is that dotted line there. So we really are operating pretty close to the theoretical limit. So the reason why we've gone for DVB-S2 on the satellite is those 2 dB are very precious.
That's meeting, isn't it?
That's the difference between 25 and 40 watts.
Well, it's Cat19, isn't it?
That's the difference between 25 and 40 watts. So don't throw it away. And I mean, that really is practical. You can try it yourself. I've tried it on the satellite. The difference between DVB-S and DVB-S2 is being received and not being received. It absolutely is there. So what does a typical transmit system look like? Where did I get this diagram?
I don't know.
CQTV 263 due out this week will have all of this in it, including this diagram. Thanks, Dave. A typical transmit system will be a PC or a ports down. I'm surprised you even put PC in there. A Lime SDR really is a practical way of doing it, although I will talk about another alternative. Your variable attenuator. Now, you've got to get to 2.4 gigs, and you can either do that directly or you can transvert up, and I'll talk a little bit more about that. Cat19. Did anybody catch that?
Must smell the food. He hasn't signed in.
Was he a member? As you saw, my dish is in the garden, and the shack is actually about, the cable run I've got is nearly 45 metres because of the way I've had to go around the houses to get along the fence to get to the dish. So everybody's finding this, that you need to put your dish where you can see a sail, and there's only one station I know, and that's GI7UGV, who is lucky enough to have a shack and a flat roof the other side of this wall where he puts his dish, and so he's drilled a hole in the wall. The rest of us have to do ridiculous things like a long feeder to get to the dish. Doesn't matter on receive, cheap and nasty satellite coax, unless you live near a TV transmitter, more than adequate. But on 2.4 gigs, because you're doing the drive in the shack, you probably will need a little amplifier to drive your 2.4 gig power amplifier. So how do you get to 2.4 gigs? Well, one option, and it's probably not the way to do it today if you're starting from here, is you can generate DATV at a lower frequency and then convert, possibly from 437. You could use a standard encoder modulator, such as a ports down filter modulator board or a DTX1 or an SR Systems or its broadcast, But the message there is it really needs to be H.264 and DVB-S capable. So unfortunately, it probably means that something like a ports down filter modulator board really isn't really going to cut it, because you need then to transvert. But our message is give it a go, get on there. If you've got a filter modulator board, we've already seen a couple of people, and I'm desperately trying to think of his call sign.
Paul M0EYT.
Yeah, yes, and there's a couple of guys using filter modulator boards. So give it a go. How do you get the up converter? You could use your existing narrowband 13 sems up converter if you're on narrowband, but the problem is this is 80 megs away from the terrestrial section down at 2320. So you'd probably have to tune it. If you've got lots of money, or there is a unit around called the DU700 from the Taiwanese.
BUs.
BU 500.
There we go. Right, prompted discussion, didn't it? I thought it was 700. there is available some transmit up converters. But we would suggest that to generate at 2400 really is the way to go. Relatively easy now. All you need is a Raspberry Pi, a touchscreen and a Lime SDR Mini. Like that. Here's one Dave built earlier. Raspberry Pi, touchscreen, Lime SDR Mini. That will generate DVB-S2 onto 400 and could go straight into a power amplifier and get you on the satellite. Thank you, Dave. You've got two options. You could do ports down, or there is some software around called the DATV Express software, which is free software, and that will drive a Pluto, the Lime, or the DATV Express card. So there's a couple of options to get there. If you've got a Lime and you don't want to go down the ports down route, just download the Express software. All of these solutions are low power and they will require amplification and filtering. You're talking about a milliwatt for most of these solutions in that order. So you're going to have to do something about amplifying it up, and to approximately probably 30 watts into a 1.2 meter dish, and you'll be able to transmit 250 kilosymbols. So you put the equipment in the shack and the PA at the dish. How much power? Courtesy Mr. Crump. See if I can explain this. Okay, so let's pretend we've got a station receiving the beacon at 5 dB MER. That's an 80 centimetre dish, or if you've got a 1.2 metre dish, you'll get it at 8 dB MER. For that station to receive you at the same level as they're receiving the signal, the beacon, for 250 kilosymbols, you, on a 1.2 meter dish, you would need 30 watts. Okay? So far, so good. And if you have a smaller dish, you will need more power. If you try and do it off your wife's 60 centimeter sky dish, you will need 120 watts into the dish. Don't forget, that's why 1 dB feeder loss is a killer. You need to reduce your losses all the way up, because these are fairly high power limits.
I have a question about this chart, because some 1.2 meter dishes are 1.4 in height, and a lot of 1 meters are, well, 1 meter.
What you're saying is define a 1.2 meter offset.
That's the trouble.
Yeah, I'll leave that up to you.
It says dish diameter.
Yeah.
Yeah.
Which means
You wrote that.
which means it's round.
Yeah.
They're not round, are they? And
Take
the
the
big-
mean of it then.
1 point, my one.
Yeah, 1.4.
I'll leave you to find out, all right? Got to be a bit of exploration in this hobby.
Well, there's a big power difference between a 1.5 and a 1.2 there, so.
Yeah. Yeah. Okay. However, if you change the symbol rate, you need less power or more power. And what this says is, this table applies to 250 kilosymbols. If you want to try 333 kilosymbols, you need 1.3% of 30 watts. Alternatively, if you only want to run 125 kilosymbols, you need half as much power. Therefore, for 125 kilosymbols, you could do 15 watts with a 1.2 meter dish. Yeah, makes sense? I'm glad I got it right. Yeah. And you could argue, okay, well, yes, he's getting 8 dB on the beacon, but if it was I could run less power and get less signal in, but still be receivable. Okay, so if we're saying, what are we saying? So we said for 8 dB MER for this station to receive me at 8 dB MER on a 1.2 meter dish, if we run 125 kilosymbols, we could run 15 watts. If we ran 7.5 watts, he'd get a 50% less power, so he'd only get a 5 dB MER. Do you see how everything is interconnected? It's the bandwidth, it's the power, and the dish size. And so what we're saying is 30 watts into a 1.2 meter dish will get you on air, and you can then experiment. Yeah.
Took me ages to work out how to present this. Though.
It really is, because there are 3 variables: power, dish size, and symbol rate or bandwidth. And how strong do you want to be into the satellite? That's the formula. But you get the picture. You need 30 to 40 watts into a 1.2 meter dish is probably a good measure. And I think most of us are transmitting and running 1 meter or 1.2 meter. The thing about a dish is it's free gain on both transmit and receive. So it's easier to get 3 dB on a dish than it is on a power amplifier, if you can hide it down the corner of the garden. So what are the PA options? This is probably the most difficult bit. You can buy new from DB6NT, etc. There are new amplifiers available. Bert, I think, in Holland does one. But don't forget, when you buy a 100 watt PA from them, they're rating it for sideband CW. So you must downrate it by at least 3 dB and preferably 6 dB for digital TV, depending upon the symbol rate. You can buy ex-commercial units primarily designed for UMTS or digital mobile signal coverage systems. But be a bit careful. Most units are designed for 2.1 gigs. They will just about go to 2.3 gigs, which is the bottom end of the amateur band. We are operating right at the top of the amateur band, up at 2.4, and I've got one that I bought from somebody in this room called a Remek, which is a beautiful amplifier. Runs about 60 to 70 watts out at 2.3 gigs, about that much at 2.4 gigs. So don't assume that you've got a big amplifier for the amateur band at 2.3 that it will go at 2.4. And the problem is it's the devices and the isolators and everything else in there. So to rework them for 2.4 is a real challenge. The best option is probably Spectrum PCB Spectran amplifiers from the eBay seller Pyro Joseph. So note that down, Pyro Joseph. He's got some. He had some last night when I last looked. I think he had 17 of them, and they're 70 pounds, and they can run up to about 50 watts. I was a bit hesitant in putting that number up. There seems to be some folklore issues around this, but in the order of 50 watts. I don't know what you're hoping, Sean.
I haven't tested it yet. Ken is most advanced, but
Yeah.
At 45, I think it's more.
Sorry?
At 45 more.
Yeah, CQTV coming out this week will have a series of mods by Mike G8LES to tweak it up. He of course reckons he can get more, but Mike would.
German DBs.
Yeah, LES DBs. 28 volts, 10 amps, 15 amps. eBay power supplies, no problem. That's a picture of it up there. They're not particularly big, but they seem fairly robust and fairly good. KLB runs ones for hours on end, as he would, and he seems to survive.
Use him as a new beacon.
It was suggested.
But that's probably the best option for us to recommend at the moment. There are other amplifiers around, other amplifiers are available. But that one probably is the best recommendation we can give at the moment. And as I say, Pyro Joseph on eBay, he's in the States, has got some for sale, and he's a reliable, good seller. So.
Is that about £25 postage then?
Sorry?
Is that about £25 postage?
Yeah.
Sure?
They operate a thing called Overseas Buyer Program now, and it's priced in dollars, but eBay converts it to pounds, but then you pay a fixed amount for postage and customs duty. So you don't have to pay the post office their fee. I bought one a couple of weeks ago, it came to £126 all in.
Yeah.
It's confusing me. It's the ham radio. As long as we mention ham radio, should be used.
We're not going there.
No.
Thank you.
No, it's 4%.
Order!
24%.
The eBay Overseas Buyers Program, Ken used it as well, and it seemed to work, and it worked well.
Okay.
No hidden charges.
So, you've got your signal, you've amplified it up to 40 watts. What do you do with it now? Well,
Plumbing fittings.
all credit to him. There is only one show in town, really, and that's Mike MJW has designed a patch antenna, which is this. And it's a right-hand circular patch, which is this bit here, on a backing plate, with a piece of 22mm copper water pipe through the middle. The reason why the copper water pipe is there is because you put your LNB on the back, and the 22mm copper water pipe acts as a waveguide. And if you cut the front end flange off any LNB, can we do that with yours?
Insurance.
You will find that it is approximately 22mm. So GI7UGV has just used a standard universal back-to-back coupler, 22mm back-to-back coupler. I've done the same, and it just hangs there. So you connect your transmit feeder there, and you hang your LNB there. This is missing one essential piece. Unbelievable. That piece of plastic there is called a lens, and you have to buy yourself a rocket LNB. Rocket is a generic description of an LNB that can be used on one of these multi LNB holders, so you can have a dish looking at different satellites. And they've designed a lens on them that enables you to stack LNBs close to it, because it's a fairly tight diameter. And you push that in the end of the 22mm copper water pipe, and believe it or not, that bit of plastic, in my instance, makes 2 dB difference on the receive side.
Increase.
You can receive the beacon just by that, but by putting the piece of plastic on the front, 2 dB, and it's basically a lens that's focusing the energy. So the thing to do, of course, is to use your standard LNB first, align your dish, get your MER number for the beacon, take your life into your hands and cut the front off your LNB. Scary first time round, isn't it? Mount this on the dish, and with a bit of judicious pruning and tuning, you will find that you should be able to achieve within half a dB the same number. Dave GKQ has found that using old microwave techniques of putting some tuning screws in here, he improved it by about...
I got a dB over what I had, but I'm not sure what I had was optimal.
Yeah. I found that this spacing was quite critical on the back end of the LMB. But before Dave said this, I cut mine off fairly short, so I haven't got room for tuning screws. John, you had it?
I was going to say a couple of things. One is with regards to the coupler on there. The way to do it is you lock the one that's on the actual patch, lock that tight, but the one that's on the LMB leave loose, because that then allows you to get the skew without having to move the whole thing.
Yeah.
So it makes setting up a lot easier.
Yeah.
When you said 2 dB improvement by putting the lens in, is that 2 dB on what the LMB would be?
No. No. It basically takes it back
Ah,
to what
what
the
it was.
LMB was before. I did try putting, so you've cut the horn off the front of the LMB. I tried putting that on here, and that was good, but of course it blocks the transmit patch, so that doesn't work. So I'll pass that round. This is not assembled yet, so that distance there is fairly critical. The distance between the two plates is critical to get the loss right, the reflective power right. Okay, so this enables 2.4 gig transmit and receive at 10.5, and you can do look through on that and two-way QSOs on that, and that is the thing that everybody is using. There's an article in it in CQTV 263 about it. So, conclusions. Fantastic opportunity for amateur experimentation. It has just opened up a whole new ball game for us. People are experimenting with all sorts of things. Receive is easy. Please give it a go. Even if you just borrow your Sky dish, the wife won't notice. Turn it and see if you can receive the wideband beacon. A good transmit capability is more of a challenge, but not impossible. It's the power that will kill you, but give it a go. If you're running narrow symbol rates, you may be surprised at what you can get in with. And all of what I've talked about is in CQTV 263, which is coming out this week. There's an article by Ian on receive, Dave on transmit, LES on the Spectrum power amplifier. There's an article on the patch. There's several articles, basically what this presentation is based on, for coming out this week sometime. Unfortunately, the editor is ill again. We had hoped to have it by the weekend. But, so start simple, get a receiver working, and you'll really get the bug. At the very least, go and have a look at the wideband spectrum monitor. So
Is there an electronic version of CQTV?
Yes.
Good.
Everybody gets that. Your email that you get sends you a download link for it.
Is it?
Yeah.
All right.
Yeah. Okay, real game changer. Get involved. Thank you very much. Any other? Any other questions? Adrian?
Yeah. Is there any chance that the shop might get somebody to produce the circular hardware? Because that's going to be a killer for a lot of people.
There are various people around who can do it. People with milling machines.
Yeah, I mean, you know,
You've got that.
Is the rocket cover tight fit?
Sorry?
Is the rocket cover tight fit?
No, it's a loose.
No, it's a loose. So the other thing I should mention is when you look at the spectrum monitor, you may say, well, why don't we stream these signals? You know, people have often said, why isn't there something on the BATC streamer so I can watch it? And the problem is that signal may be on for 30 seconds. This signal might be on for 2 minutes. Another one might pop up there. Another one might pop up there. Which one do we stream? It's just not practical at the moment because each one has got to be done manually. There's no automated way of decoding this at the moment. I know various people are working on one, but for the moment it's just not practical. What you may find is that various kind people who have got receivers and mini-tuna can, using a little batch file and FFmpeg, they can stream it onto a channel on the BATC. And we've done that for a couple of our repeater nights so people can get a flavour of what's happening. But right now it's impractical for us to set up a streaming channel. We would if we could, but it's just impractical to do it. Any other-
Sorry.
Yeah.
Is it going to be necessary, do you think, to have some sort of advanced scheduling? Because this could get quite popular, couldn't it? Really? I know it's not ideal for amateur radio, but...
No, I think it will just work itself out. I mean, at the moment it gets busy at certain times of the day, but other times of the day there's nothing on there.
No, I don't know. It depends
Well,
how it goes,
maybe it will, but I'm not sure.
in the future, maybe.
I mean, we just use this chat channel to
Yeah.
coordinate
Yeah.
things, and it seems to work.
Fair enough.
Remember that if there are lots of people on there, there are lots of people want to watch them as well.
Yes, true, yeah.
So
True, yeah.
it's self-regulating to
No,
some
it's,
extent.
Yeah.
no, it's only a thought. You know, I mean, I can, being that it's got such a broad
Yeah.
geographical coverage, you know, there could be quite a few people.
I mean, at the moment it's
upload.
really only Europe that we've seen, but
Yeah.
hopefully we'll see a bit more.
Yeah.
Talking of experiments, one of the experiments that's been done is how close can you get signals without interfering?
Yeah.
And you
Yeah.
can get them so you can't see the difference between them on here,
Yeah.
and they still.
Yes, we've had 4 signals within a megahertz,
Yeah, so not.
and you can still tell
Yeah.
mini-tune which one you want to decode.
And Phil's automatic symbol rate thing
He's
said,
going mad.
"Oh, this is one big signal."
It's good. No, it's good. No, impressive.
Any more questions?
Is that behind you? Is that a direct feed or is it live?
Yeah, that's live.
It's live.
Yeah.
Okay.
That's from the dish out in the
Oh,
garden.
okay. Yeah.
No, just on that Spectrum power amplifier, so it's 2.4 gigs. Found Pyro Joseph, it's a PC board only.
Yeah, that's right, yeah. It's called amateur radio.
No, it's just, there were some other references to
Yes.
the chassis as
No,
well.
it's it's PCB.
I'll get a book.
Yeah, he has in the past, and he may in the future
Well,
get.
he bought a
complete
whole
modules.
load of the complete
Yeah.
200 watt amplifier boards.
I think
making much more money stripping them down and selling more
Yeah.
piecemeal.
Any other questions?